Welcome to Spring LIB.
Is that for this equation, for this wave, the assumption that the amplitude is much smaller than the wavelength implies that the maximum velocity of the wave, which is defined as v prime, equals the derivative of big D with respect to t. This velocity is much smaller than the velocity of the wave. So the transverse speed of the string is much smaller than the wave velocity. So we want to show that this will imply this. So how do we do that? I think the easiest thing is to first figure out what v prime is. So to take the derivative. So with respect to t, there is this coefficient omega. Negative omega is an a. The sine will become cosine. So it's this value. And the maximum happens when the cosine equals -1, and this becomes omega times a. So this is v prime max. So what is v? V equals f times a. In omega is 2 pi f times a. Sorry, this is f times lambda. Typo. So f times lambda, and this is 2 pi f times a. So if a is a lot smaller than lambda, then f times a, because f is positive, will be a lot smaller than f times lambda. So because it's so much smaller, so adding a 2 pi actually wouldn't hurt, because 2 pi is around 6. If a is so much smaller than lambda, even timing it by 6, it will still be so much smaller. So then 2 pi f a is v prime max. So that's how a much smaller than lambda indicates v prime max is so much smaller than v. In other words, the transverse velocity of the string itself is so much smaller than the wave velocity. Part B says if we have a equals lambda divided by 100, then what will be v prime max over v? For that, we can just plug in the expression. So this is 2 pi fa, and v is f times lambda. So this gives us 2 pi times a over lambda. A over lambda is 1 over 100, so this is pi over 50, which is 0.063.